Hello everybody, welcome back to From Rhythm to Algorithm, part 44, Asymmetry. Last episode we talked about syllogism, just how equations in logic relate to statements of logic. So we're talking about asymmetry in language, right? The universe expands, it expanded, the mechanism of expansion was inflation. So what kind of results do we have in our language about that? And just keep talking about syllability and more analysis. We're going to start with a result. We're going to end with a very simple, direct question, and we'll provide some linguistic analysis and talk again mainly about linguistic analysis today. We'll try to make some statements about numbers, but we'll just keep our analysis going. But the first thing I want to start with is a riddle. Full disclosure, I did not derive this, heard this at a campfire, I think at like a family thing, but I heard this and just understood the logic. I did not figure this out myself, and I don't know what it is a result of. You might have heard the riddle before, but I'm going to answer it right away, so if you want to try to answer it, pause the video right as you hear it. So you're walking down a path in a woods, and there's a fork in the path. And on one path leads to, let's say you're really hungry. One path leads to food and safety, and the other path just leads to nowhere. And there's two people. One person only tells the truth, and the other person only tells lies. And you only have one question, and you can ask either person a question, and if you get the question correct, you can go down that path. And obviously you want to get to the path with food and safety. So what question do you ask those people and why? So pause the video if you want, I'm going to explain the answer right now. Well, you ask either person what the other person would do and then do the opposite. And that's the result. And the logic is, right, if you ask the guy who only tells the truth what the other guy would do, he would tell you that the other guy would lie. So you would do the opposite of what the liar would do. If you ask the liar what the truth guy would do, he would tell you a lie, so you would do the opposite of what the liar does. And I put that's a result. It's certainly a logical result, but it's a logical result of what? I think it's a logical result of chirality, but again, just the verbiage, fork in the road, either or, you ask the same question to either person reduces to the same correct logical result about, truth or false, binary, zeros or ones. That's some sort of riddle result of logic for sure. That's just where I wanted to start. I was thinking about that today. Again, did not derive that myself, just understood the riddle. But again, right, I told you, physicists anonymous, I'm not sure what chirality is. I can solve all of these things, all these results, and simple riddles still make me think, or I can't figure them out on the spot, stuff like that. But syllability is the structure, or is the number of syllables. We've said that in a previous episode as our novel definition. Now we're going to change that to the syllability is the structure of syllables, right? Because we've talked a lot about basis and range, but let me just read a couple statements. The structure of syllable is asymmetric because of our universal physical expansion. We have our one, too many number system results. We've talked about 1 and 2 being complete, or in the past is complete. But how does the one-way expansion affect antonyms and synonyms, right? Very clear thing everyone's talked about in early school. But antonyms are direct logical opposites, but synonyms are similar. Similars are not the same thing. Remember our identity result of language, of logic, of syllogism, A equals A, infinite biological uniqueness. Each person's unique, each word has a unique definition. We talked about ordinality in the last one, so we can say all of the statements are ordinal, whether they're words, letters, or sentences. In past sentences, like any argument is composed of sentences, any book, any research paper, any conversation. Let's just look at some examples, right? Full, what's the opposite of full? Empty. Right? Full is 1 syllable, empty is 2 syllables. Motion versus emotion. In a previous episode, random correction, I said emotion is the basis of motion, or the base of motion. Being consistent with numbers, base 1 syllable, basis 2 syllables, we'll get there. But motion, right, you can have planets without people, you can't have people without planets, certainly not for like evolutionary consideration, but motion, 2 syllables, emotion, 3 syllables, basis, range, right, so subtle logical nuance, but this is a direct logical paradox, right? We said a range has more syllables, is more comprehensive, is emergent, describes more things, is more applicable. Well, basis simply has 2 syllables and range has 1, so the correct term is base. The opposite of base is range, not what's the opposite of basis? I don't know if that's the right question, but it's a direct logical paradox. One-way expansion of the universe, we already talked about that. One-way expansion of words. Again, just considering how words are defined or how they're solidified with their functions in their contexts. But right now we have a clear definition: base, range, 1 syllable, 1 syllable. Now uniquely, math, 1 syllable, language, 2 syllables. Can you construct a modern gauge theory? Yes, if you put lang on the end, or on the front of gauge, language. So that's pretty cool. But there's our 1, 2. Our many is our base 3. And I say now trying to put numbers on. I have vibration, 3 syllables, 3 unstable, only open systems. Dimension, direction, right? Dimension and direction. Clearly the prefix die is typically indicative of 2, and mention and rection are not full words. So that's a solid definition. We'll talk more about the linguistic analysis now, but then I also have 7 question mark again, considering counting through numbers. So we'll talk about we'll do some numbers now, but we'll do linguistic analysis, let's talk about some numbers, and then I'll leave you with a very simple question. So now just talking you through some linguistic analysis and results. Again, not a novel result, but diphthongs, right? The historical one that I want to reference was just the A and the E. 1, because they're vowels. 2, because it's clearly like a geometry result as well. But why do diphthongs exist, right? Same syllables, contraction, and rhythm. Just when you're speaking in a given context, it's more efficient to use less syllables. But diphthongs are a result of contraction and rhythm and efficiency. That's just a thing that exists now. But getting back to the iteration function, or I said it was a function, or I said it was an operator, but that's just flatly incorrect. Remember, at the very beginning, functions contain operations. So a function ranges an operator. A function range contains a base. Functions contain operators. So iteration is a function. And so now we're just going to try to list that function, or talk about that function, or demonstrate how it works. But just the first result, in all contexts, we can say range contains base. All right, we've modified that from in math class, you'll say basis, but that's two syllables is more than 1. Can't prove me wrong, Ed Witten, IAS, you guys, nanner boo-boo, stick your head in doo-doo. But it's, right, now we go from 4 letters to 5 letters. See, look how awesomely consistent that is. That's pretty freaking cool. But we've also removed our is statement, right? Is relates an analogy, direct metaphor for all contexts. But to the iteration, just a statement. Iteration is a function of language, right? Language, 2 syllables, math, 1 syllable. Language has more range than mathematics, specifically to, right, the vocabulary of the species, just what people have said anywhere, like literally any statement on any video, any book, any letter, anything, is a lot more than the formal ontology, right? 3 million-ish theorems known, but clearly a lot more than 3 million statements every single fucking, I don't know, minute, hour, all of the time. But how about just a logical, linguistical demonstration of iteration result? Right, discrete versus discrete. Discrete being non-conspicuous, subtle, not obvious. Discrete being clearly defined physically. Right, so iteration is discrete, a stepwise function. So I just have our elements, right, our base 3 again. Sum 2 is complete, 3 is our first element. We're just reading through the natural numbers. 3, 4, 5, 6, 7. From our geometry, we rotate the 8 to say infinity, like literal physical infinity. You can't measure the boundary of the universe, and that's an open, not including the boundary because we don't know. So that's our unknown, literally that paren. But we have 5 jumps. 1, 2, 3, 4, 5, 6 elements. 1, 2, 3, 4, 5 jumps. A jump is a discrete step. So that's our iteration function. So what can we say about 5 steps and apply that to language and to numbers? More to the alphabet and to numbers. Let's make sure I'm still rolling. So just more evidence, right? In complete generality, there are 5 types of conjugation or 5 conjugation classes. I, you, he, she, or it, we, them. All right, a formal you, ustedes or ustede, I don't fucking know. Formal is not a unique class. But direction versus dimension, again, just another. We've been trying to say right now, very clear that 3 is the base of physics. Dimension, like literally the word dimension and direction. 1, 2, 3, 4, 5, 6, 7. All right, they both have the prefix di indicating 2 and then 7 letters. But this analysis should have some implication to that statement. And that's why I have closed brackets. But now base, let's just again talking about direct linguistic iteration. Right, base is a word. Base with a C is not a word, but ace is a word. Right, we talked about the preservation of pronunciation. We can look at the syllable or the letter B as modifying the syllability of ace. So base, B-A-C-E, and ace, right, defined mathematically, if you ace something, you get 100%. So what you have is the letter B modifying the syllability of the word ace, which is a direct iteration of numbers in order, 1, 3, 5. And so we're at 3 prime numbers, but a unique one-way iteration universally, or expansion universally. So that's why I have them closed brackets. So, right, that's why we have 3. You can say like 3 is the only number, the presence. Historically, you might have said trinity. But we can now just, again, generalize our result. We said, language is the range of math. Well, that's why there's more letters than there are numbers. So that's kind of our final result. We have now derived why there are more letters of a given alphabet. Any of them, there's typically more than 3 numbers, or 1, 2, 3, 4, 5 steps, or even 9 numbers. I don't think there's any 9-letter alphabets, but that's why we have now derived, after 44 lecture series, videos for math and physics and language, along with the other legal series, and all the other shit of me thinking to say we can confidently say we should have more letters than numbers. Cool beans. Now let's end with one final question. Is the opposite of right left or wrong? Thanks for watching part 44.